We want to explore the galaxy. We constantly build faster ships and more efficient rockets, searching for ways to cross the staggering distances between the stars. But Albert Einstein drew a line in the sand. That line is exactly 299,792,458 meters per second, the speed of light. It acts as a literal physical wall built into the architecture of our universe. As you try to approach that wall, reality itself starts to warp. First, you experience length contraction. The actual physical space in front of your accelerating ship compresses. Then, time dilation kicks in. For you, the traveler, the ticking of the clock slows down relative to everyone else left behind. The universe actively bends your foundational experience of space and time solely to prevent you from crossing that speed boundary. There is a third consequence to approaching this limit: mass inflation. As you accelerate, your relativistic mass increases. Your ship becomes increasingly heavy to the energy pushing it forward. This equation is the Lorentz factor, governing the energy required to accelerate mass. Watch the denominator. If your velocity reaches the speed of light, c, it collapses to zero. The energy required to push further instantly spikes to infinity. There is not an infinite amount of energy in the entire universe. Because of this mathematical breaking point, normal matter is hard-coded to stay below the speed of light. Brute force acceleration is impossible. But theoretical physicists often skip the acceleration phase entirely. By plugging numbers directly into the other side of the wall, the math projects an entirely inverted reality. Welcome to the realm of tachyons. Proposed in the 1960s, these are hypothetical particles that are born traveling faster than light, sidestepping the problem of acceleration. Looking at these quantum field theory calculations, we see a strange requirement. To keep relativity's equations from breaking down, tachyons must possess imaginary mass. Multiplied by the square root of -1, it implies a deep instability in the vacuum of space. The physics here act as a complete mirror image to our universe. For normal matter, adding energy speeds you up. For a tachyon, losing energy causes it to accelerate. As its energy drops, it shoots toward infinite speed. To slow a tachyon down toward the speed of light, you have to pump infinite energy into it. The speed of light is a two-sided mirror. We are trapped below it, tachyons are trapped above it, and the glass separating us is a wall of infinite energy. Because space and time are inextricably woven together in relativity, moving through space faster than light guarantees moving backward through time relative to certain observers. This introduces the tachyon antitelephone, a device that uses these particles to send a signal into the past. This timeline illustrates a severe causality nightmare. Imagine firing a faster-than-light weapon at a distant target. To an observer moving at a certain speed, they would see the target detonating before you ever pulled the trigger. Being on a ship moving this fast would offer a bizarre visual experience. If an object flew past you, you would see it appear out of nowhere, and then two identical images of it would split and fly away in opposite directions, one moving forward in time, the other moving backward. This image shows a faster-than-light effect in a nuclear reactor. The glowing blue light is Cherenkov radiation, created when a particle exceeds the speed of light through a medium like water. Breaking the absolute speed limit in the vacuum of space might generate a similar glowing cosmic shockwave. Traveling faster than light is impossible for reasons beyond just energy limits. It destroys causality, the foundational rule that a cause must precede its effect. Because pushing straight through the barrier destroys the logic of reality, modern physics looks for loopholes. We need solutions that respect the rules of relativity rather than breaking them. People often look to quantum entanglement, where two particles react immediately to one another across galaxies. But this doesn't bypass the limit. Their states are perfectly correlated, but no usable information or matter traverses the space between them. A true lateral solution completely changes the parameters of the engineering problem. This is where theoretical models like the Alcubierre warp drive come in. This topological grid visualizes the core mechanics. Instead of trying to push a ship through space, this model suggests bending the space around the ship. By compressing space directly in front of you and expanding it behind, distance itself moves. The ship remains stationary inside a localized warp bubble, avoiding mass inflation and the penalty of time dilation. The speed of light is the load-bearing architecture of space and time. To cross the universe rapidly, humanity doesn't need to build infinitely faster engines. We have to learn how to fold the fabric of reality itself.